Hello DSI 2000. In this video, I will be introducing you to data manipulation in Excel. So what we're going to do in Excel is we're going to cover everything that we've done so far with base R and dplyr. I just want you to know in advance, I'm not a fan of Excel and Access. The main reason I'm teaching you these tools are because I find that they're necessary evils. A lot of companies are resistant to using coding to automate their processes, and they might only want to use point-and-click tools to do their data-related work. I will also mention that Excel and Access was where I got my start. When I first entered the industry, I was using Excel and Access for 40 hours a week. And it wasn't until years after that I had finally been able to get a job where I could use programming to do my data analysis. So although I don't like Excel and Access, there is value in actually knowing how they work. Another thing that you should know is that there is a programming language that is designed for working with Microsoft products called VBA, or Visual Basic for Applications. I'm not going to cover it in this class. I'm also not a fan of that language. If you ever find yourself in a position where you have to rely on VBA to automate your processes using Microsoft products, I strongly recommend this book called 101 Ready-to-Use Excel Macros. I found that this book, when I was using Excel and Access to automate my processes when it came to data analysis, that this book was extremely helpful. There are two terms that you should be familiar with when it comes to point-and-click interfaces. The first one is GUI, G-U-I, standing for Graphic User Interface. This is just software that you interact with using icons rather than a command line. For example, most software that you work with in Windows is a GUI, such as most Microsoft products, as well as things like Chrome and Internet Explorer, things like that, where you just don't have a command line. Another type of software you'll hear about in the industry is what you see is what you get, with that acronym. These are just programs that output product identical to what you see in the program, such as Word. For example, in Word, when you type something in a page and you print it, what you get from your printer should be exactly what is in your Word document. So it's a what you see is what you get type of program. Let's talk about Excel. A few things you should know. Excel and most Microsoft products went through a massive interface change back in 2010. As a general recommendation, I recommend that when you're using Microsoft products, that you stick with Microsoft Office products that were created in 2016 or later. Features often get added or dropped from version to version, so you should be aware of those differences if you find that you're using things like Excel or Access to do data analysis. Another thing that you should know about doing data analysis in Excel is that there is no easy way to keep track of the steps that you've done in an Excel document. You are not using code to do data analysis in Excel generally. You cannot use things like Git or GitLab to perform version control on Excel. So if you're going to keep track of changes you've done to an Excel file, you should either just save changes as you hit milestones and document as much as possible, either within the Excel document or through a text file in the same folder. Another thing that you need to know about Excel is that it cannot open more than 1,048,576 rows or 16,384 columns. If you attempt to open a file in Excel that exceeds either of these row or column limits, Excel will randomly drop data from your file. There have been unfortunate news stories where people have tried to open such large data sets within Excel only to find later their data is gone. So please be aware of these limits. There's some XKCD comics that you can read too if you would like. So let's talk about how to just do the things that we did in R in Excel. The first thing we're going to do is we're going to learn how to read in a data frame into Excel. Go to your data files folder and open up simulatedmnsalaries.csv in Excel. Now, one of the things you need to know is that Excel will annoy you to no end if you attempt to open a CSV using Excel. Excel will not actually save everything you do in it unless you save it as an XLSX file. Here's how you do that. Let's go to the left over here and go to File, then Save As. Let's go to Browse, and I'm going to go back to my DSI 2000 folder. Let's create a folder called Unit 6. And next to Save As Type, let's choose XLSX. And now that we're in the Unit 6 folder, please hit Save. So now Excel has stopped complaining. And we have also read in a data frame into Excel. So that is how you read in a data frame into Excel. This is just warning you that Excel will not save everything you do unless you save it as an Excel workbook, which is an XLSX file, and we just went through how to do that. Before I go on, I want to just point out one thing. I am not committing this Excel workbook at all to Git, because when you save files like this, you could exceed the GitLab memory limits. So I'm choosing not to git add and git commit this XLSX file. I just want you to know that. So here we are filtering for records for which sex is equal to F, year is equal to 2008, and race is equal to white. How do you do this in Excel? I want you to click on data at the top and then click filter. These will create filters for every individual column. For year, you can click its filter, click the select all to unselect everything and just choose 2008. And then we want sex equal to F, just hit select all and then F. And then for race, hit the filter, hit the select all button, and let's just scroll down to white. So that there is how you get the records for which year is equal to 2008, sex is equal to F, and race is equal to white. Observe that Excel is not at all keeping track of the clicks I did to get here. If you want to save this, I strongly recommend you just go to File, Save As, and then you save this as its own copy. But for my purposes, I'm not going to be saving this. I just want you to know how to do this. Whatever will help you in making sure you understand these steps, just make sure you take note of it somehow. I'm going to clear out the filter just by clicking filter again, and let's go on. So in dplyr, we had also filtered for values for which sex is equal to F and sex is NA. All you would do in this situation is as follows. Under data, go to filter again, choose the filter next to sex, and just uncheck M so that F and NA are selected. And that is how you do that. Let's get rid of the filter again. And go on. Let's talk about renaming columns in Excel. So in Excel, we had renamed ID to new ID. This is how you do it in Excel. Simply double click the cell that says ID, select the text, and just replace it with new underscore ID. That is how you change column names in Excel. I'm going to hit Control Z just to reset it. Selecting particular columns. So here's how you select only the year and salary columns in Excel. I'm going to select column A. Observe how this arrow appears when I'm over column A. I'm just going to left click there. Then I'm going to hold Control and do the same thing for column D and column E. Then I just right click and hit delete. That is how I select only the year and salary columns of this data frame. I'm going to hit Control Z and let's go on. Now let's talk about how to show unduplicated values in Excel. In dplyr, what we had done is we had shown all possible pairs of race and sex in the data frame. Here's how you do that in Excel. First, I might suggest just getting rid of columns A through C first. You can click on column A, hold Shift, and click on column C. Holding Shift will select every column between A and C in this situation. Right click, click Delete, and with columns A, and then I'm going to shift click B, selected, go to data, then go to remove duplicates. Choose both columns, sex and race, and make sure that my data as headers is chosen. Press OK. Then Excel will give you this dialog box, and you can see if you scroll through here, all the possible pairs of sex and race in these data. I'm going to hit Control Z several times just to reset this back to its original state. Let's talk about creating new columns. In dplyr, what we had done was we had created a new column called Salary Canadian, which was 1.33 times the salary value. Here's how you do that in Excel. The first thing I'm going to do is I'm going to go to the right of the race column label, and I'm going to double click and just type salary underscore Canadian there. I pressed enter, and now I am in cell F2. Salary Canadian is 1.33 times the corresponding salary value. Here is how you do that calculation. Type equals 1.33 times and then you select cell C2. Press enter, and then you should get a value right there. Now we need to extend this for the entirety of column C. Here's how you do that. Select the salary Canadian value that we just generated. Then at the bottom right, there's this little notch right here. I want you to please double click that notch. And what this will do is it will generate salary Canadian for the entirety of that data frame. So that is how you create a calculated field in Excel. I'm going to Control Z just to reset everything. We had also talked, and I had asked you to do this on your own, about values that change depending on a Boolean condition. In dplyr, the way we did this was we created a new field using mutate, and then we used case when to generate a different value depending on where the salary range was at. In Excel, what you would have to do is you would have to type this entire thing in one line. I am not going to do this. I highly suggest that you do this yourself. Here is how you read the syntax. If C2 is less than 9,526, return 0.1. Otherwise, if C2 is less than 30,701, return 0.12. Otherwise, if C2 is less than 82,501, return 0.22, and so forth until you either hit a condition that C2 satisfies, and if C2 satisfies none of these conditions, it just spits out 0.37. And you would have to put this entire formula in one line in a cell in Excel. This is called a nested if statement. The reason why it's called a nested if statement is because there are if statements nested within if statements, hence a nested if statement. I will let you do this on your own. Here is some humor for you. If you thought those if statements were crazy to put on one line, here is actually a very, very long formula that you could throw into one cell in Excel. You're probably wondering what in the world this is. This is actually the day on which Easter occurs in an Excel formula. You would have to throw this entire formula into one cell in Excel and press enter and hope that it works. Please do not do this. If you find that you're working with Excel formulas that are this long, I would rather you just program this in R. Because at least with R, you can comment out your code and you can at least explain what the code is doing and why you're doing what you're doing. In Excel, you don't really have that option if you throw this entire formula in a cell. Another thing I want you to be aware of too is that organizations have lost hundreds of millions of dollars due to spreadsheet errors. People who use spreadsheets are often not trained in doing data analysis with programming. And at times, people decide that they may want to throw a massive formula such as this one into a cell whose value that neither they nor anyone else can validate is actually working correctly. So I just want you to be aware of this. Let's talk about sorting by columns. So in dplyr, what we had done is we had sorted by year and salary in descending order. Here's how you do this in Excel. Under the data tab of the ribbon, click on sort. We're going to tell it first to sort by year in descending order, which is largest to smallest. I'm going to add a level and then salary from largest to smallest. Let's press OK. And here you can see that we have sorted by year and salary in descending order. I'm going to hit Control Z just to reset the data frame. And let's go on. Aggregation in Excel is generally most easily done using what is known as a pivot table. We're going to use pivot tables to demonstrate aggregation. The one thing I'm going to let you know of that I know of unfortunately from experience is please do not use pivot tables for final reporting to managers. They're nice when you just need a quick summary of what exists in the data, but they are very hard to customize and they're extremely hard to work with when you have data that is changing constantly. In one of my very first jobs, I was asked to create an Excel spreadsheet with about 50 or so pivot tables in it. And in addition to that, the data were changing constantly. The problem with pivot tables is that they do not update well when your data are changing. Oftentimes they will not at all. In the situation I was in where I was creating 50 pivot tables in one Excel spreadsheet for a changing data set, every time the data would update, I would have to manually go through every single pivot table and reset it. it. That is hours upon hours upon hours of work that could have been saved if I had just been given the option to just automate these data analyses. Another thing with pivot tables too is that they can get often very complicated, and given that Excel cannot keep track of the clicks that you do, you may not be able to replicate a pivot table exactly correctly due to factors such as just not knowing how to create a specific pivot table in a particular form, or you may have done some things with the data that just won't be recorded in Excel. So long story short, please don't use pivot tables. I've seen people fall into this trap all the time. So let's talk about calculating mean salary by year and sex. Here's how you do that. I have selected a cell inside the data. I'm going to create a pivot table so I can perform aggregate statistics. I'm going to press insert and then pivot table. And it by default will guess what the table's cells are, which is correct in this situation. And it will also ask me where I want the pivot table report to be placed. Generally speaking, I like to keep it in a new worksheet so I don't modify any existing data by accident. Let's press OK. And now we've started creating a pivot table. What we're aiming to do is we're aiming to calculate average salary by year and sex. One way you could do this is as follows. With a cell selected within this pivot table, I'm going to go to the right, and I'm aggregating by year and sex. I am just going to throw year and sex under rows. Here's how you do that. I'm going to select year right here, just click and hold it, and then drag it to be right under rows. I'll do the same thing for sex. And then if you look on the left, you can see that values of year and sex are starting to be populated. Going back to the right, the next thing we need to do is we need to calculate average salary. When you need to perform a function on top of a numerical statistic, you generally put it within values. So I'm going to click and hold salary and drag it to values. By default, Excel is choosing to use sum right here. I need to change this to be the average. So I'm going to click this notch to the right over here. I'm going to go to value field settings. Then I'm going to change this to average. So here we now have average salary by sex and year. So this value right here, for example, is average salary for females in 2008. Here's an alternative way you could do this. If you want this layout, you would have to throw the year in the rows and the sex in the columns. Let's go ahead and do that. So sex is in rows right now. I'm just going to click and hold this and then move it to columns. And that is how you get that layout. Another thing I had asked you to do in dplyr was to perform that same calculation, except for Asian records only. The only difference between what we just created using a pivot table and this one is that it has an additional filter added on to only show Asian records. We just have to add that to the filter section on the pivot table. Let's go ahead and do that. On the right over here, I'm going to add race to the filter. So I just click and hold, drag it to filters. Go to the left, and we're going to choose Asian. So this is average salary by year and sex for Asian records only. Remember that Excel is not keeping track of any of these clicks that you've done. And that's all I have for you. Because we cannot commit Excel documents through Git or GitLab without worrying about memory limits, if you want to save the spreadsheet, you may. I am not going to save it, but you can just hit Control S to save it if you want. For now, I'm just going to delete the worksheet that has the pivot table. So I'm just going to right click it and hit delete. If you want to keep it, you may. Yes, I do want to continue. And this is just the original data as an XLSX file. I'm just going to hit Control S and it's saved. And that's it.